In this video, you'll learn how to assemble the SafeDrive project. It involves wiring up many digital pins within the Arduino board. So let's get right into it. To start, you need the Arduino Uno. This is how we will be able to upload the code to control all of the hardware throughout our project. You're going to use this connector in order to connect both the Uno and your computer. You also have a USB end at the other end, so please connect it to your computer. And once you do this, the Arduino Uno should power up and you should see a light flashing right over here. Before we upload the code and actually look into what the Arduino does at a software level, let's understand the hardware that goes into this project. The first major thing I will assemble is the LED circuit. To do that, we need a couple of things. The first major thing is obviously our LED. You can choose any sort of color. In my case, I have green over here. And we also have a resistor. Now, the reason why we need a resistor is because the LED cannot handle the current that will be fed to it directly through the Arduino. So if we were to hook up directly this into the Arduino, the LED will blow up. Now, for the size of the resistance, it needs to be from 220 ohms to 1 kilo ohms. The shorter side of the LED is the cathode, whilst the longer side is the anode. The cathode refers to the negative point, and the cathode refers to the positive point for the current to flow. In the case of the resistor, there is no positive or negative end, so you can put it in any orientation that you wish. On top of all of this, we are going to need a breadboard, and this is because we will need some place where we can actually put all of our components and connect them up. A breadboard is a very nice alternative to soldering, as you can easily take things out and switch things, so it's perfect for prototyping. In the breadboard, the columns are electrically connected. So if you were to put 2 points in the same column, then they would be connected as if they were soldered together. The opposite is true within the power rails. So these parts that you see over here. In that case, the rows are electrically connected. On top of all of this, we're going to need some wires as well. Here are some of mine. They need to be male to male, meaning that they all have this leading stick on them. There are multiple digital pins on the Arduino. They basically allow you to control the flow of current. In the case of the LED, we are connecting it to the Arduino digital pin of 13. So that's exactly what I'm going to do here. I'm going to locate 13, which is right here, and I'm going to place a jumper wire there. And then that jumper wire is going to go into any sort of position on the breadboard. It doesn't really matter. So in my case, I'm going to put it in the column of 5. We now connect our resistor to the same column as our digital pin 13. This way, we're electronically connecting both the pin 13 with our resistor, which will allow us to restrict the amount of current that is flowing into our LED when we start wiring that up. So we're going to put this in the column of 5. Like so. So it's in the same column. And then the other part, the other leg of our resistor, it doesn't matter where it goes. It can go here, here, here. Doesn't really matter. I'm going to put it in the column of 15. Like so. Make sure that your components are fully flushed into those 2 pins so that you're able to actually get a solid electrical connection. We will now wire our LED. Since we're using the digital pin of 13 and restricting the flow of current from there, that is the positive part of our current. So that means we have to use the anode of our LED when connecting it to our resistor. So that's exactly what we're going to do. We're going to use the longer part of our LED, and we're going to put it in the same column as the end of this resistor, so that the resistor basically takes all the current and it restricts it so that only a certain amount of it flows through, and then that's what we're going to be exposing our LED to. So I'm going to put it in the same column, the column of 15, and I'm going to put the other end, the cathode, over here. Currently, the flow is not completed as there's no ground or a negative part for all of the current to flow into. So that's what we will do next. Before we do that, I want to make use of the power rail. So this is where I'm going to take the negative part and I'm going to take one of those positions and I'm going to connect it to the Arduino ground pin, which is right here. As you can see, it says GND. Now I can use this whole row and it will connect to the negative part of our Arduino. So I'm going to take the cathode of our LED, which is in this column right over here, and I'm going to be connecting it into our power rail. Now you have a full current going through. Now we're going to test to make sure that this code works. To do that, I have some test code over here that I'm going to upload into my Arduino. So you need to go onto the Arduino IDE. Once you're on there, you need to go into the boards and connect to the corresponding board. You can see that by taking out the current connection and seeing which one goes away. And that would be the board that you're connected to. Once you're there, click on it. And then after that, in your actual code piece, add this syntax where you're going to have a setup function and a loop function. Within the setup function, you want to set pin 13 as the output, which you do through this syntax, where you have a pin mode, the pin, which is 13, and then we're setting that as an output because we are not using it as an input. Then in the loop, you want to use the digital write function. This allows us to override the state of the pin so that it can either be high, where it's getting the full current possible, or low, where it's getting no current at all. Right now, I have it as low just because I didn't want this to turn on yet. But now what I'll do is I'll switch this to high and let's see if everything works. Okay, I switched it to high. And now if you want to upload this onto the microcontroller, ensure that you have the actual wired connection. And after that, you want to click a few buttons. The first one is this button over here, the checkmark button, which will verify that there's no syntax errors. So when you click on that, you'll notice that it says done compiling. If it has some sort of error, then you'll need to fix that. In my case, I'm good. And then afterwards, you want to press this arrow button like this. And that will actually upload the code and we should see some sort of effect. So let's do that right now. And as you can see, once I do that, the LED lights up, meaning that this whole circuit works perfectly. This component that we'll be hooking up is the buzzer. And the buzzer uses the Arduino digital pin of 12. So let me just go ahead and sort that out. So I first connected it to the digital pin of 12 on the Arduino board, and I can bring that on to my breadboard wherever I see fit. In my case, I'm going to put it right over here, like so. And that is at the column of 25. We take our buzzer and let's add it directly into this digital pin. So we're going to use the positive end, which can be found through looking for the positive symbol, like so. And we're going to put it in the same column as the digital pin so that those two are connected, whilst the other part goes into this column over here. And then I just need to push it down so it's nice and flush. Following the same logic as the LED part, we need to finish the flow of current. So I need to take a jumper wire. Usually this would be black because that would signify negative or ground, but unfortunately I ran out of black wires. But if you do have a black wire available, just use that to keep it consistent with the color code. And then we're going to put it into the negative rail, like that. We will again have to make sure that the buzzer works. So we will upload some test code that I have over here. In this case, as with the LED, you need to ensure that the digital pin of 12 is an output. And then afterwards, within our loop, which is the core of our functionality, we're going to run the tone function, which will generate a nice sound. And in this case, I'm generating a 1000 hertz sound in pin 12, which is what belongs to that buzzer. So as with always, we need to verify our code, and we can do that through the check mark. And as you can see, it tells us that it's done compiling, so we can just press the upload button. And as you can see, you can hear a sound, which means that this buzzer is working perfectly. To get rid of the sound, it's very simple. You can just delete this code, and again, verify to make sure there's nothing wrong, and then upload. And as you can see, the buzzer has stopped buzzing. Next up, we will connect the LCD display. The LCD has an I2C module, which makes it more simpler for wiring, as instead of having to do 16 or more connections, we only need 4. Now that module has female connectors, which means that we need these wires, where you have your male wire and you have your female wire. The wires that are required are the ground, the VCC, which is our 5 volts, and an SDA and SCL. SDA is basically, you can think of it as the data line. It allows you to send information, whilst the SCL allows you to control the timing of the sending of information. So let's start by wiring the ground pin and then the VCC pin. Since the LCD uses the 5-volt power from the Arduino, it's appropriate to connect the positive rail of our breadboard to the 5-volt pin, which is right beside our ground pin over here. And you want to make sure that everything flushes out very, very nicely, like so. We will now add the female to male connectors onto our I2C module. In my case, the ground is the brown wire. I didn't have a black one, unfortunately. And we can just put that into the power rail of our breadboard. The same thing holds true for our VCC pin. The VCC pin is going to go in the positive rail of our breadboard so that it connects to the 5 volts, as this is connected through this jumper wire over here. Usually you would use red when you're connecting directly to the positive power rail. That's just a convention, but unfortunately I didn't have a wire available for that. So all we have to do is take this and put it into the positive end like so. And as I do that, you'll notice that our I2C pin, or the module, is lighting up like this. This is good because it tells us that our module has been powered up effectively. Also notice that the LCD has lit up, but it's giving you these weird characters, and this because the data pins, which are over here still, haven't been connected. So let's do that next and run the text code. The SDA pin, which is this wire over here, needs to go in the analog pin of A4. And the SCL pin, which is over here, needs to go into the Arduino analog pin of A5. Like that. We'll be running some test code on this LCD display. And to do that, here it is. We need a library, which is called Liquid Crystal I2C. So you want to search that up in your library manager, which can be found through these books. And you want to install this one from Martin. I already have that installed, so I'm good to go. Once you're done that, you need to initialize the LCD. And we do that by giving it the address of the I2C module. And you can find that through the scanner sketch, which I'll leave in the description below. And once you have that, you just put that address here along with the amount of characters per row and then also the amount of rows themselves. Then in the setup, you want to start the LCD through the init function and you want to turn on the backlight. After that, within the loop, we want to set our cursor to the to 0 of column and row, and then we want to print hello world. So it just makes things much easier when managing our LCD display. So then I will press the verify button to make sure that there's no errors, and then I will press the upload. And once I do that, you'll see hello world. In the code that I've provided, there are pins 9, 8, 7, 6 for rows, and 5, 4, 3 for columns. So let's start off by just adding all the jumper cables into this wiring and then wiring it into the Arduino. Here are all of the wires connected onto the connector of the keypad, and now we need to wire it all into the Arduino. The keypad connected to the Arduino. As you can see, within the Arduino, we start off at pin 9 over here, and we work our way down to pin 3. So from pin 9 to pin 6, we have our rows connected, and then from pin 5 to pin 3, we have our columns. As always, we're going to do testing to make sure that this component works. And for that, this is our test code. We will Continue to be having the liquid crystal I2C, which is basically just going to allow us to control the LCD because we're going to be displaying the keys that we press on the LCD display. And then we also have the keypad library. That allows us to manage the interactions that we have on this keypad. This is a configuration that is needed to set up the keypad library. And then within the setup, what we're going to do is we're going to initialize the LCD, the backlight, and we're going to clear anything that might be there from before. And we're going to set the cursor to the first column and then the first row. And then we're going to print key pressed. And then within the loop, we're going to be running the keypad, which is what we did from the initialization, and we're going to be running the get key function, which will allow us to essentially retrieve a specific key that is being pressed. If no key is pressed, then we return and we move on to the next loop execution. But if there is, then what we will do is show the most recent key pressed. And we do that by setting the cursor, so where we're going to be writing to the second row and then printing out a clear line to ensure that there's nothing else. And then after that, we're going to be printing out that key value. So let me go ahead and compile this code. And then we're going to be uploading it. Now, once I do that, you'll notice I see key pressed because that's what I added within my setup. And then now if I input something, let's say the pound, I actually see that. So that means that the Arduino is registering the different keystrokes that I make on this keypad. So everything works properly. Now we will work with the DC motor. And this motor has a fan attachment to create a stimulant for our user in waking up. We need an external power supply for this to work, as the Arduino natively cannot support the amount of voltage and current that is needed to power this DC motor. However, the Arduino is still needed in controlling when this motor should be on or off and at what speed. And to do that, we will use a special component called a transistor. I like to think of a transistor as a valve. Essentially, it controls the amount of water that can flow into the dam. And in this case, that water is electricity and that dam is the DC motor component. The resistor has 3 pins, a base, a collector, and an emitter. The base is the control pin, and the collector is where the power comes in, whilst the emitter is where the power goes out. So this is basically what happens when a transistor is used. When it doesn't have any sort of signal from the base, it is off, meaning that no current is able to flow through. But if a small voltage is applied from the base, and that comes from the Arduino digital pin, then the transistor will turn on. And then the large current, which comes from our DC motor, will be able to flow through properly. That is the entire point of this transistor. Look for an identifier on the actual NPN transistor, which you can find through just reading the text right here. And afterwards, paste that onto Google and search up the pinout diagram. This will tell you which pin belongs to what. So in my case, the first pin is the collector, the second pin is the base, whilst the third pin is the emitter. Switch to a new transistor. It's still NPN transistor, meaning it will still have the base, collector, and emitter, but the pin positions might change. In this case, when you have it on this end, where you have the curved end facing towards you, well then the collector is the first pin, the base is the second pin, and the emitter is the third pin. And that's how I'm going to be wiring this circuit. So please be aware of that fact in case your positioning for your NPN transistors might be different. Now, we can put it in the breadboard wherever we want. In my case, I'm going to put it in the column of 50, the collector in the column of 50, like so. You want to make sure it's nicely flush so that you get a good electrical connection as always. Start off by wiring the base of this transistor. To do that, we need a resistor along with a jumper wire so that we can connect it to one of the Arduino pins, which will be used to control the DC motor. This is because the base pin is the control pin of the transistor. It is what determines whether current should flow through all of the components connected to the transistor or not. And that's exactly what we want to use our Arduino pin for, the digital pins that we've seen throughout the LED and the buzzer. We cannot directly connect the base with the pin because if we do that, we risk it's sucking up too much electricity, leading to things breaking and heating up. So we're going to connect a 1 kilo ohm resistor. So what you want to do is you want to go to the column that belongs to the base pin, and you want to insert the resistor like so, like that. And you can fix the orientation of that resistor and stretch beyond that column into another column, which is this column right here. And that's fine. It's just that now when we connect the Arduino pin with the jumper, we're going to put it here instead of somewhere around here because we want the current to flow through the resistor first. Now let's connect the Arduino pins. So you want to connect this part, one of the wires, into the column that is right after the second leg of that resistor, like so. So they're in the same column, as you can see. And then you want to take the other part and put it into a specific pin. In our case, our code defines pin 10 for the fan. So we want to go into our Arduino, find pin 10, which is right here, and you want to insert it right there. Next up, let's connect the emitter. To do that, we'll go to the last pin on our transistor because that is what is associated with our emitter. And in this case, we want to bring that emitter to ground. It's finally time to set up the DC motor. Before we can do that, we need to set up the external power source. You want to take your snap connector, which is how you're going to connect your 9-volt battery, and you want to take the positive end of that and put it in this power rail over here. It's very important that you do not put this in over here, because if you were to put it in the power rail that has been already connected to the 5 volts of the Arduino, you could cause lots of very expensive damages. So please do not do that. Put it in a power rail that has not been connected yet. Then you need to take the negative and put it in the negative of the Arduino. So in that case, you must put it in the negative power rail that is connected to the ground of the Arduino so that you can create a common ground. And that way you basically are able to create a complete loop for your current when we use it within the transistor. So take this and just put it in any open spaces that we have on the power rail for negative. I have one right here. So I'm just going to go ahead and insert it. Now we take our DC motor and we take the negative end of that and put it in the collector. So that would be right here. The positive end of this DC motor will go in the positive of our external battery source, so you can put it in this power rail, which is associated with that external power source. Almost done, but there's one thing that has been remaining to do, and that is to insert our diode. So why exactly do we need this diode, and what does it even do? Very simple. A DC motor stores energy when it's spinning, and when you suddenly turn it off, that energy has nowhere to go. So basically what happens is that the motor tries to force this energy back into the circuit as a high voltage spike. And that spike can severely damage or overheat your transistor and other components. So this flyback diode basically gives that energy a safe escape path. It absorbs that shock from that voltage spike. So here's how we wire this properly. The diode has both a positive and a negative. The longer leg is the positive, while the shorter leg is the negative. And the positive side should go within the negative of the motor. So this is the motor, right? The negative wire for the motor. That's where the positive end of the diode should be placed. So you're going to go ahead and find a place within the column, because remember the columns are all connected, and you want to just place it right there, just like that. Now, the negative end of the diode will connect to the positive end of the motor, and that is connected to this power rail. So all we need to do is extend this leg a bit so that we can reach the power rail. Exactly like that. I fixed it a bit by straightening it out a bit and also by pushing the diode's legs greater into the places where they need to be. Now you can take your battery and connect it into the snap connector, like so. As always, we're going to be testing to make sure that the fan actually turns on. And the way we're going to do that is through this code. We have the digital pin of 10, and we're basically writing a digital write of high, where we're going to be giving this pin the largest amount of current possible. And that should allow the transistor to power up, and because of that, allowing the flow of the current to be satisfied for this fan to turn on. So let's actually run this. And to do that, you need to press the verify to make sure that there's no syntax errors. And then let's run the actual command. And when we do this, that the fan turns on perfectly. If you want to turn the fan off, you can simply digital write low so that it will turn off the pin fully. To upload the source code that I've developed for this project. If you want to get your hands on it, you can simply go to my GitHub, Hemit Encode, and search for the Save Drive repository. In there, you'll see a hardware.eno file, and that's where all the Arduino code lives. So now all we need to do is press the verify button to make sure that everything compiles very nicely, and it's working on that right now. The code has nicely compiled, so we know it can be used for uploading. So you need to just press the upload button. And once you do that, the project will update.